All right, so let's take some notes on quadratic equations. Quadratic is an equation that starts with a variable that is squared. As we've been classifying polynomials, you saw that anything in this format was considered the quadratic. This was a quadratic monomial. This is a quadratic trinomial. And this is the standard form of a quadratic equation. A is some coefficient of x squared, B is the coefficient of the linear term x, and C is the constant. And so this is a typical standard form for a quadratic equation. When graphed, a quadratic equation creates a U-shaped curve called a parabola. You've probably heard Mr. Gattani call it a parabola before. Use your graphing calculator to sketch the following. So I would suggest you all pause this video, get a graphing calculator, put this equation in, and see what shape it makes. So if it's been a while, let's review how to use the graphing calculator. You're going to turn it on, clear anything out, and you're going to go up to the y equals button that is just above the second function. You hit y equals, you're going to clear out any, equation that's in the y1 line. And we're going to type in x squared plus 2x minus 5. So to hit the x button, you could hit the alpha and then locate the button to the left of the number 1 called store. And there's a little green X above it. But there's a quicker, easier way. Just below the second button where it says alpha, and just to the right of alpha is an X button. So if you hit that X, then you want to hit the caret. The caret is that little upside down V that's above the division sign. Then hit the number 2, plus 2 again to the right of alpha is the X, and then minus 5. And remember, minus and the little negative sign, which is under the 3, are two different buttons. So you want to hit the minus sign. All right, now that we have our equation in, you're going to click on or press the button for graph. And as long as your window is kind of in a standard spot, you'll see this parabola come down, and I'll draw it for you here, and up. And we put the arrows at the end to indicate that the parabola is continuing on in both directions. So it makes kind of a smiley face. If A is positive, remember that's the coefficient of the quadratic term, then the parabola opens up like a smile. Conversely, if A is negative, then the parabola opens down. Okay, so you can take a moment to pause this video. You could put in for y2 the second quadratic equation here, and you'll see them both kind of superimposed over each other. You could clear it and just graph the negative one, but it's also kind of fun to see the two on top of each other. So I'm going to go on, assuming you've now paused the video, put the new equation in, seen that it opens down, that the leading coefficient here, the A term, is -1, and that's what causes it to open down. So we're going to move on down. We have a new concept for quadratics. This vocabulary term is very important that you understand what is the axis of symmetry. This is where I find that one of the biggest misconceptions in this unit comes in, because when we talk about the axis of symmetry, we talk about it in conjunction with the vertex. Okay, and now there's another vocabulary word. So I'm not sure how to add a page here, or even if I can. So I'm going to draw off to the side. When you have a parabola, we'll just open it this way. You will have a lowest point. Okay? Here, this will be called your minimum. And we're going to get to this here, I think, in the notes. Minimum. If it opens down, because it's negative, you're not going to have a minimum, you're going to have a maximum. And there's an imaginary line that runs through the middle, like an X value, the X value of this point, right? And that line is the axis of symmetry. So the official definition we're using here is the vertical line that divides the parabola into two equal parts. The formula for the axis of symmetry, because you do kind of have to calculate it, is x is equal to negative b over 2a. And if you have ever seen the quadratic formula, you know this is actually a key piece of the quadratic formula. Okay? Negative b over 2a, that is the formula for the axis of symmetry, which is not the location of the minimum or the maximum. It is the line that travels, the x value that travels through the center, dividing that parabola into two equal parts. Now, how is that confused with the vertex? Well, the vertex is the blue dots that I drew on those parabolas. The vertex is the xy ordered pair location of the dot, where the axis of symmetry, think about an axis. When the Earth rotates on its axis, it's kind of like the imaginary pole that goes to the center of the Earth and it rotates around that center, right? The axis of symmetry is like that pole that cuts the parabola in half. But it's just an x value because it is a vertical line. It's the line that cuts through the center. So it's just an x value. The vertex, however, is the ordered pair. It is the turning point of the parabola. When the vertex is at the lowest point, is called the minimum, and highest point is called the maximum. Sorry, I'm not getting these right on the lines there. Find the axis of symmetry and the vertex, then sketch each parabola. So we said that the axis of symmetry is the line, the x value. Well, we don't know what x is. We have to calculate it. So we're going to use our axis of symmetry formula. This x equals negative b over 2a. And so we have to identify the a term, which is a 1, and the b term, which is 8. And so we're going to say x is equal to negative 8 over 2 times 1. So x is equal to negative 4. Again, this is a vertical line, and that is the axis of symmetry. X is equal to negative 4. I should write x is equal to negative 4. Okay? The vertex, however, is a location. It's the point that is the minimum or maximum. And we know the x value is 4. Well, how do I know what the y value is? Think about that. I have an x value. I need to find a y value. Well, isn't this equation a function? Can't I put the value in for x and find out what y is equal to? Sure. So I'm going to write here x squared, which is negative 4 squared, plus 8 times x, which is negative 4, plus 15. And I got negative 1. So when x is negative 4, y is negative 1 on the parabola. Now it says to sketch it. So stop, pause the video, put this quadratic function, this equation here, into your graphing calculator, into the y equals section, clear everything else out, then hit graph and watch it graph, and then draw a sketch of it. Do not put the vertex value in. where I drew here, y equals -4 squared, don't put that in. Put the original underneath the blue, where the blue is rectangled here, the examples. You're going to want to put this into your graphing calculator. Then you can sketch it. Okay, so even I paused the video and did what I had suggested. And I now have put it in, and it sketched just like this. So it's all mostly to the left. It's about to cross through the y-axis on the right side of it. We know that at -4 is our axis of symmetry. And we know the vertex is at -4, -1, which makes sense, right? I mean, that looks about where that point is and is our minimum. Okay, so there's a whole page of these that you have been given, and we want you to go ahead and work these out. Okay, and you're going to need to start with the axis of symmetry formula. That's your starting point. Find your x term, put it back into the equation. Find your y term, put the equation in, graph it, and sketch it. So you'll be able to calculate the axis of symmetry, calculate the vertex, and then sketch it. And if you want to do color pencils or markers that you can kind of like highlight what the axis of symmetry is, draw a focus on where the vertex is, kind of like I did here, because anything you can do to appeal to your senses helps with memory and retention. But either way, we're after the math, and good luck. I'm next door if you have any questions.